Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, meet me again, Miss Ara, in science lesson for grade 4. So I'm going to explain about light. Okay, since next week we are going to have a quiz about this unit 5, and then the week after next week we will have ACE 3. So hopefully this video can help you to prepare for ACE 3. Okay. So we are going to talk about the light, and then this is the first subunit. It's about how we see things. Okay, so how can we see things? The first one, the objective is to investigate how we see things that are not sources of light. Okay, since then make predictions and see if results support our predictions. Make conclusion from our results, and then it's stated on your learner's book, page 96 to 99, and then what is light sources? Okay, we know that light sources is something that is producing light, such as the lamp, the sun, and then the other thing you can choose whether you can identify whether this object is light source or not. Okay, and then the next one, I have ever asked you to provide a shoe box and then make two holes on its on the lid. Okay, and then put a flashlight in one hole, and then don't forget to put an object inside of the box, and then turn on the light, and then you see how you can see the coin. Okay, you can try to turn off and turn on the flashlight, and whether if you turn on the flashlight you can see the coin clearly, right? That's how you see the things. You see things. It means that the light from this arrow represent the light from the light source, which is in this experiment or investigation is the flashlight, and then it hits the coin, okay, here, and then the coin, and then it's reflected by the coin to our eyes. So that's how we see things. Okay, and then yes, this is the diagram of how can we see things. Okay, so it means the light from the light source, which is the sun, and then it hits the book, and then it hits it is reflected by the book to our eyes. So that's how we can see things. And then light travels in straight lines. Okay, so the objective is to investigate how light travels, and then make a prediction and see if results support our prediction, and then make conclusion from the result, and then draw a ray diagram. Okay, so it's on your workbook, page 99 to 101. And then first, let's see how does it work. How does the light travel? Okay, so you have to provide flexible plastic tube and a flashlight. Okay, I have provided these two materials in your science kit, so just take it and prepare those materials. Okay, and then yes, actually you can do it on your own. You don't need anyone to help you actually. So you have to put the flashlight in one end of the plastic tube, and then the other side you have to see through your eyes. Okay, and then there are some shape of the plastic tube. Since the plastic tube is flexible, so you can try to see the light through the straight shape, and then bend shape, and the curved shape. Okay, and the result is you can see the light that comes from the flashlight clearly when you see through the straight shape. Okay, what about if it is bent? If it is bent, for example, you cannot really see it. Okay, since we know that the light is supposed to be travel in straight lines. Okay, so if the light travel here and you are trying to see from here, so you cannot really see it clearly. Okay, and then what about the curve? Okay, what about the curve? You cannot see it completely, since yes, that's right, the light cannot go through the curve shape since it's straight. Okay, we have ever proved that one as well. Okay, the next is about light rays. What is light rays? So if you see the light, and you can see this like straight lines, like the beam near each narrow beam. Okay, this is called the ray. Okay, this one, the straight one, the straight thing. Okay, so that's why when you find a picture, okay, anything you find a picture of a sun, for example, sun, you will see this light rays, okay, around the sun. So this means that, oh, this object is a light source, and then it it's producing light, and there is light rays around the sun. Okay, so it means that the sun illuminates light. And then light travel in a straight way. Each narrow beam of light is called a ray. Light rays travel from the source of light in all directions. So that's why you see, if someone is drawing sun, it means that she or he always put the light rays around the circle, around the sun, right? Not only in one side, but all direction. Okay, so here, we have identified the first picture, and then let's move to the second one. See, you see, this is the light rays of the sun. And Miss, there is a lamp. Why the lamp is not a light? It's not a source of light. Yes, since it's a day, okay, daytime. So we know that during the daytime, to save the electricity, we don't need to turn on the lamp, right? So that's why you cannot see any light rays from the lamp. So that's why it means that during the daytime, lamp is not a light source. Okay, since the main light source is the sun. Okay, so the light from the sun, it hits the car, and then it is reflected to the man's eyes. So that's why the man can see the car. Okay. You can do the practice workbook page 61 to 62, and then workbook page 63 to 66 about how can we see things and light travels in a straight line. And then the next one is about light reflects off different surfaces. Okay, so the objective is look at examples of how well a mirror reflects light, and then investigate how well light reflects off different surfaces, and then make prediction and see if results support our prediction, and describe simple patterns in results and make conclusion. Okay, so I wanted all of you, I already told all of you, and in this subunit to look into the mirror, and then what do you see? Try to see your reflection, the perfect reflection with the light on and off, and what are the differences between them. Okay, so since we know that reflection process always requires light, so let's see how about if you turn on the light and if you turn off the light. Okay, and then I'm sure if you turn on the light, you can see your perfect image on the mirror. Okay, but if you turn off the light, you cannot really see it clearly, since the reflection is not maximum as well. Why can we see our face in the mirror? Okay, so mirror has a smooth and shiny surface. This allows us to see our reflection on the mirror. Okay, so this is the mirror, and it's very smooth and it's very shiny. It's very slippery. That's why we can see our reflection through, on the mirror. And then we call the reflection of our image of our face in the mirror is our image. So this is the image, and this is the real girl. Okay, the texture and structure of the surface influences the object's capability to reflect light. Yes, since you cannot see your image clearly or perfectly in all objects, only some objects that has smooth and shiny surface and slippery surface. Okay, and then we cannot see our reflection on a rough and bumpy surface such as wood and wall because they absorb the light. So instead of reflecting light, they absorb the light. Okay, you know that the differences of absorb and reflecting, right? Reflect, it means that, okay, so when it hits something, it will be reflected, but when it is absorbed, it means that it will continue being absorbed by the object, some kind of that. Okay, that's differences between reflect and absorb. Don't be mistaken. Okay, and then this is the investigate how well different surfaces reflect the light. So I asked you to identify some objects around your house, that whether and investigate whether these objects is it able to reflecting light or not. Okay, and please fill in the worksheet in Class Dojo I have assigned about which surfaces reflect light better. Okay, and then the next one is about light in our solar system. This is your favorite topic supposed to be, right? So the objective is to discover that solar systems can contain stars, planets, asteroids, and comets. Stars and planets are different. You know the differences, right? Stars can produce its own light, and planets cannot produce its own light. Asteroids and comets are the other objects that also can be found in our solar system. And then name the planets in our solar system. So there are 8 planets in our solar system. Okay, 4 of them are, let's say, small planet, and 4 others are big planet. And then draw a diagram of a moon orbiting a planet. Use a model to show the relationship between bodies in the solar system. Use reference books and the internet to find out more about the solar system later. Okay, so let's talk about the sun and the orbits first. Okay, so wait, let me erase this. Okay, so the Earth is the planet. This is the Earth. And the planet is the body that goes around the sun or orbit the sun. And then the sun is the star. Okay, the sun is the star, is a star, and it's usually much bigger than any planets orbiting the sun, I mean. And then the moon is the satellite. Okay, that, and it goes around the Earth. Along with the Earth, it goes around the sun. Okay, and I would like to remind you one more, that the star can produce its own light. Okay, so the star do not need other object to produce light, and then it reflects the light. No, the sun can produce its own light by fusion reaction between helium and hydrogen. And then the moon orbits, or the goes around the Earth. Okay, so the moon goes around the Earth, and then the moon takes 29 to 30 days to orbit the Earth, and it's same as its revolution. So the moon takes 29 to 30 days to orbit the Earth, and it also takes 29 to 30 days to spin on its axis. The Earth orbits or goes around the sun. Okay, so the Earth goes around the sun along with the moon's revolution. The Earth takes 364 quarter days to orbit the sun. So it takes 364 quarter days. Okay, wait a minute. Okay, the solar system here cannot really represent, this picture cannot really represent the real one, since actually the sun is much bigger than this. But let's see. Okay, the solar system consists of the sun, the planets, moons, comets, and asteroids. Okay, this is the sun. Oh, I should use black. This is the sun, and this is the closest planet to the sun, which is the Mercury. And then this is the Venus, and then this is the Earth, and this is Moon. This is Mars. This is Mercury, and then this is Jupiter, Saturnus, Uranus, and Neptune. Saturn, Uranus, and Neptune. Okay, so there are 8. 1, 2, 3, 4. 4 small planets, and 1, 2, 3, 4. 4 big planets. Okay, and there are 8. And then planets that are closer to the sun than the Earth take less than an Earth year to orbit the sun. Planets that are further from the sun than the Earth take more than an Earth year to orbit the sun. Okay, so Mercury is faster. Okay, 1 year, we know that 1 year equals to 1 time that the Earth orbit around the sun, right? So 1 year for Mercury is shorter. Why? Because the orbit is shorter. Okay, the orbit of the Mercury is shorter. So the time that Mercury needs to complete 1 orbit is also shorter. Okay, so that's why the meaning of planets that are closer to the sun than the Earth take less than an Earth year to orbit the sun. That's the meaning of it. Okay, and planets that are further from the sun than the Earth take more than an Earth year to orbit the sun. Okay, so further, if the planet is further, so the time it requires to take 1 orbit is longer. Okay, so if you notice in this solar system model, Pluto is not a planet. Okay, Pluto is a dwarf planet, and since the orbit of the Pluto cut the orbit of the the orbit of Neptune, so it is not considered a planet anymore. So because the planet supposed to be orbit goes around on its orbit. Okay, it's not allowed. I mean, maybe scientists say that if since the Pluto's orbit is not proper, so it is not considered a planet anymore. And this one is the orbits, no, the objects between Jupiter's and Mars orbit. It is called asteroid belt. Okay, so there are so many asteroids there, but asteroid is smaller than. Okay, so here is the asteroid. So asteroids are rocky masses that orbit the sun, and they are similar to the planets but much smaller. At the moment, scientists have identified 781,692 asteroids. Nearly all of them are in the asteroid belt between the planet Mars and Jupiter. Okay, so like I told you, the asteroid belt, okay, it's like not massive, but a lot of asteroids there. So that's why it is called asteroid belt, and all of them are going around the sun. And then the second one is moons. Moons, it means moons is used to for all natural satellite that goes around any planet. Okay, so it's a general. And then moons orbit planets and asteroids. Okay, Earth has one moon, Mars has two moons. This photograph shows Titan. Okay, this is called Titan. It is the largest of the moons of planet Uranus and the 8th largest moon in the solar system. Okay, so that's Titan. And then comets. Comets are lumps of ice and dirt which move in large orbits around the sun. Many comets are beyond the planets at the edge of the solar system. Comets have long tails behind them. So sometimes we see the comet. It's like this is this. It looks like a star, okay, but it's look like falling star. But actually, it's a comet, okay. So comets, it goes around the sun, but the orbit, the shape of the orbit is not circular. The shape of the orbit is more oval. Okay, so that's about the comets. But don't forget that comets are lumps of ice and dirt. Okay, so it's not only rocks like asteroid, not only solid matter like the moons, but it consists of lumps of ice and dirt. Okay, this is the practice for making a solar system model. Okay, and then day and night. Okay, so this is Atta's video about day and night. Hopefully this explanation will help you. Okay, and wait. Okay, so let's see something then. Okay, so here. So this is how day and night happen. Okay, this is the Earth axis, and this is the sun rays. So the sun is somewhere here, and then it produces light, and this light hits the Earth. Okay, and okay hits the Earth, but not all part of the Earth, only some part of the Earth. Okay, but the part that is that gets light, okay, from the Earth, it experience daytime, and then the other part which is not, I mean, which doesn't get the light, it experience nighttime. Okay, so that's basically how does it work. We have ever done an experiment about this. Okay, like when I ask you to put, I mean, to what is it, to imagine, to assume that the sponge ball, okay, is the Earth, and then the flashlight is the sun, and then when you try to give off the light from the flashlight to the object, and then you spin it around, so it means that in some part, okay, it gets light, but in some other part it doesn't get light. Thank you, Atta. Okay, so this is globe. Globe represent the Earth. Okay, but since I cannot give all of you, each of you, globe, since you are at home, so that's why I changed the globe with the ball. Okay, the sponge ball. And then the globe is a model of the Earth. It is shaped like a ball. Okay, so it's round like a ball, and then there is a stick passing through it from the North Pole to the South Pole. Okay, and this is the Earth axis. Okay, oh, I'm sorry, let's say this is the Earth axis. And then in the space, the way the Earth move is not straight like this, but it's tilted, mirroring. Okay, it's tilted about 23 and a half degree tilted. Okay, so it's moved like this, not straight like this, but tilted. Okay, then the Earth turns round and round or spins all the time on its axis. If it is stopped, it means that something bad happened. If you look at the top of the Earth, that is the North Pole, and the Earth spins in an anti-clockwise direction. Anti-clockwise direction, it means that it's the reverse of the opposite of the clockwise direction, because it doesn't follow the clock direction, which is to the right, but it's to the left. And the Earth does one complete turn on its axis every 24 hours. Okay, so this is what I ask you to do, but I replace the globe with the ball and the small stick. Okay, so that's why you can spin it around while you are illuminating the sponge ball with the flashlight. Okay. And then the practice is on workbook page 75 to 76. And this is the last unit about investigating shadow length. Okay, so you remember about shadow, right? You have already learned about this in grade 2, if I'm not mistaken. The objective is to explain changes in shadow in terms of Earth spinning on its axis. So we are going to identify whether, oh, miss, if during the morning the length of the shadow is quite long, but when the sun is getting getting higher, okay, until noon, so the shadow will reach its shortest shadow. Okay, make prediction and identify if results support our predictions, measure the length of shadow and describe simple patterns in results, repeat measurements to get more reliable data, and make conclusion from results. Okay, so the first, yes, I would like to remind you what is shadow. How can we make shadow? Okay, so what do we need to make shadow? We need a light source, of course. Some of you said, Miss, we need a dark room. Yes, okay, but instead of dark room, we also need a light source and then screen. Okay, to put the shadow. We cannot make a shadow without screen, right? And then an opaque object to block the light. If it is not opaque, it cannot block the light. We cannot form a shadow. So you can use your hands as the opaque object. How shadow can be formed? By blocking the light. So you block the light and then you will see some shadow. Okay. And then here are two pictures, two flags. Okay, like I have already told you, this flag, the first flag, it has length, I mean longer shadow than the first one. It means that the first flag, it can be on in the morning. Okay, so this is the shadow of the flag in the morning, or in the afternoon. Okay, but for this one, it's definitely during the noon time. Okay, since the shadow is very short. Okay, but light and shadow. Okay, so the boy tried to explain that when the it's okay. This is in the morning. Okay, when the sun is not really. I mean, it's in the morning, so the sun is at in the east direction. Uh, the shadow is like this. Okay, so it makes the shadow in this direction. Okay, and it's continue, what is it, in the opposite direction. If the sun is here, okay, so it means that the shadow is here in this in this side. I mean, if the sun is in the east, so it means the shadow will be in west direction. Okay, and for example, this is the sun, and the next one is at noon. Okay, so the sun looks like above us, really straight in our head, for example. Okay, so that's why the shadow is very short. Okay, it's just in front of the tree. Okay, the next one, late afternoon, it's same as in the morning but different, in the opposite direction. So we know that sunset is sunset in west direction, and then that's why the shadow is in the east direction, or in the east part. Okay, so this one, I ask you to identify the pictures whether if the sun's position is here, so it means that it will producing light and hits the man, and then the shadow that it produced or it formed is this one. Okay, so this one, the first shadow, it's supposed to be, it's in the east, and this shadow is in the west. Okay, so it just passed through, not passed through, I mean in the opposite direction of the sun itself, the light source itself. Okay, so this is how you investigate the length of the shadow. Since I have provided the Play-Doh and the stick, so you can try this on your house. Just try to, what is it? To draw the shadow. Okay, at 9 a.m., 10 a.m., and then 11, and then 12, and then 1 p.m., 2 p.m., and 3 p.m. So you can compare later. Okay, which shadow is the longest and which shadow is the shortest one. But since it's raining, I can understand if you say that, Miss, I cannot do it since it's raining. It's always raining in the morning sometimes, in the afternoon sometimes, so it's fine. Just try to see this is the result, okay? The result of Alicia's and friends' investigation. Later, I will re-explain about this if you need to, okay? Okay, so this is the practice for book page 78 to 80. Okay. So everyone, that's all from me. Okay, hopefully this explanation can help you, support you in studying for your IS preparation. Thank you very much. Okay, wassalamualaikum warahmatullahi wabarakatuh. Have a nice day.